Hi everyone, welcome to the second part of this project to design and 3D print an adapter or hat for these old lithium-ion batteries. In the first part we took some measurements from the battery and then modelled the hat in Fusion 360. Then at the end we exported a prototype of what we've done into Cure and then sent it out to print on my aging ANET A8. Now, as some of the more discerning of you may be able to guess, that has since finished printing, and we can gaze at its loveliness and try fitting this hat onto this battery. Oh, okay. So as many of you may have expected, there are one or two minor tweaks that may need adjustment. Obviously this is a little bit too tight. And also, if we have a look in here, you can see that the angle here is somewhat different to the angle here on the battery. There's also quite a bit of a gap, as you can also see, between this green tab and the slot where it's supposed to fit into. And if we try and fit that green tab through the slot, we find it's a little bit too tight. It needs a bit of extra clearance. Also, we find that even if it was fitting together perfectly, these little tabs on the battery that we carefully modelled up onto these slots here wouldn't actually fit. I've actually got them extending the wrong way. They need to extend down to this surface that the top of the battery rests upon. But that's the good thing at the moment, because if they were even in the right location, they're not actually going in deep enough to reach those slots. But that's the great thing about having a 3D printer. You can spit out a quick prototype of your design that proves exactly where you've gone wrong and where you've goofed up. So let's go into Fusion and set about correcting some of these things. So first things third, let's fix the easiest issue, namely things being a bit too tight. We need to increase our clearance. Remember, we were using our user parameters found here under the Modify and Change Parameters. We have our value for clearance set here as 0.35. So let's just increase that just a little bit to 0.4 of a millimeter and click OK. That automatically applies to all of the dimensions that we referenced the clearance value to. Hopefully that will make for a better sliding fit. Then we can move on to looking at making this angle more correct. We go down to our timeline, hover over our sketches. We can see that sketch 4 is the one that references that. Let me double click that. I must have goofed up whenever entering this value when we first did this. That's far off what we wanted it to be, 120. But we can change that and click on Finish Sketch, and there we can see that has solved that. Now, along with that error, I also made an error in this sketch. If you see these dimensions here and here, I've referenced those to the wrong surface. I referenced them to the bottom when I should have referenced them to the top. So it's easy enough to solve. We just click on the one that we don't want there anymore and delete that. And then press D for dimension, and then we can add the dimension from the top of the lug to there. And we can enter that again, which was 7 millimeters minus the clearance. click enter. This bottom one, we can remove that, and actually we can change that, because what we had in our model was a rather large gap. So we can reduce that instead to 1 millimeter and click on Finish Sketch. We can also change the depth of this particular feature just by hovering over and then double clicking on the extrusion for this. Here is minus 66 millimeters. We want to change that to minus 58. Why minus 58? Well, the longest lug, which was only just touching the back wall on our printed model, is 9 millimeters long. And so I've reduced the depth of this by 8, so all 3 lugs should now engage into that back wall. Now we can do something about this area here where the green tab fits in on the battery to lock it in place. And we can try and find our sketch for that. That's sketch number 5. And we just needed to make this a little bit wider. So we can just double click on our dimension there, and we're just going to add 2 millimeters to it. Give it plenty of clearance. Now we can see that that has offset that, so we need to constrain that to the midpoint. No, not going to allow me to do that. Easier just dimension there to there, and that needs to be just 45. That puts it in the center. We can finish that sketch, and that hopefully will solve that issue. Now we need to solve an issue where these 3 lugs or slots for the battery lugs are not all the same height, and also not coming through to the top, which we do actually need. So we find their sketch, double click on that. So we can see we only actually put the height, or specified the height, for this first one. So let's just increase that to 12, and we can do the same for each of these. And finish sketch. And that gives us a nice correction, hopefully, of those particular issues. So we can just go up and save this, and if we wanted we could print another prototype out, but I'm not going to do that, as we've got a few more features and things that we want to add before we do the next prototype. So this is the microswitch I'm wanting to use. I chose a microswitch because I'm wanting the ability to quickly interrupt power to the soldering iron, so that whenever I release the button, the soldering iron will be just in standby mode. It'll be really handy when I just don't want the soldering iron burning away while I'm doing other things, and as soon as I press a button on the soldering iron, it'll heat up within 5 or 6 seconds, and then I can just press this button to be able to interrupt the power and put it back into standby mode very, very easily. So first of all, we want to get the overall dimensions of our microswitch. Just of the main body and terminals. I'm just wanting a simple way of mounting this switch into the body of the battery hat, as we're calling it. We just need a rectangular pocket sunk into it from the same face as the battery mounts to. Then we only need a small opening through the opposite face for this roller to poke up from. And we can use the mounting holes in the microswitch to fix it in place, either with a couple of grub screws or press fit pins. We're just making this length a little bit longer to allow clearance for the wires to get soldered onto the switch. And then we'll extrude this. Leaving just a 1mm lid or surface at the bottom. Then we need a hole for the button itself to poke through. Now we can model up the mounting holes onto the side, through the side. I measured up these mounting holes locations earlier. If I just select all of these and make it a construction line, then we can draw the actual mounting holes, which need to be 3mm, and we can also do a counter bore of 5mm. Now we can extrude both these center ones. Depth -20. See, that's cut all the way through. If we open that sketch up again, extrude, and then do a cut of -4, close that sketch. You can now see we've got counterbores for the heads of the screws to hold that switch in place. Now in this particular battery, it's made easy for us as both the positive and the negative terminals have been marked clearly. But I need to measure up just exactly where those are so as to transfer this onto our model. So as you can see, I've already zeroed my measuring sticks to take into account for this lip here, which is what I'm measuring off. And I'm just measuring to the near side of each one, 11 and 27. Then I can measure exactly how wide these openings are, not forgetting of course to re-zero our measuring sticks. 1.8, 1.8. Now what I'm going to use for the contacts is this, a little piece of brass shim stock. It's 6mm high and about 0.5mm thick. It's reasonably free of corrosion. It's very easy to solder to, and most importantly, it's something I already had, which is exactly the sort of price that I like. So let's make a new sketch on this rear face here. Basically we're wanting to make two little rectangles. Let's just dimension these. One making these 1mm wide because when printing it out I know it's going to be narrower than that, and I still want to be able to push these contacts through once this has been printed. Measure from there to there, and we can put in our dimension from before, which was 11mm. 11, and we want to add 0.4 because remember we're making it 1mm wide, this slot, and the gap on the battery was 1.8, so this will hopefully ensure that those contacts will be central. +27 0.4. And hit E for extrude. Select both of these. Take it all the way through. Now if we turn round to the back side of this, we can also add a little bit of a recess to both of these. Just cut those back. And this will allow room then to be able to solder on the wires to those brass contacts. But we now need a way to get the wires from our terminals through to our switch area. Let's just do it a simple and easy way. Let's create a sketch. We're going to select on the inside of this recess here. Simply create a circle. Let's make it 5mm. Let's see how. Yep, that's okay. And we can extrude that. Cut through both chambers and into that. There we have a passageway that links through to our switch area. But we also need to provide a recess in this side wall along here, because otherwise we will not be able to get the switch in and out because the wires will be obstructing it. And we also need to extend that recess and create a space in here so that some slack can be had so that it is actually possible to wire it up once everything is in place. So let's do that now. Create a sketch on that inside wall. It's a bit awkward to see what we're trying to do here. There is a better way of doing this, but for now this is the way that we're just doing it. Extrude that to cut in. Let's just move our view to see where we're going with this. We have to be careful because here we are actually cutting in a bit too far. That should be alright. Very easy to get a bit confused with this. So you can see from here we've got our recess in here. We now need to create a recess in here so that we can have somewhere to put our slack from our wires. It's great to be able to just adjust our viewpoint when we're doing this. Makes things much easier. So we can extrude that, and we can make quite a big recess in here. That'll give us plenty of room. We just need to make this actually a bit altered. Dimension that, and then let's dimension that. Hang on. I need to remove that. Now, it should let me do it. Too many constraints stopping me from doing what I want to do. That should do. But we just need to adjust now the selection. There we go. To better see what we were doing, what is a better way to do is to add a section analysis. This allows us to make a cutaway view. We can actually see exactly how things are and make any alterations that are needed, such as I see this little area here is very, very thin. I'm going to see if I can adjust that just to make that a little bit thicker. We go back to our extrusion here. We can move this, change this to -2.5. That's better. And we can always turn on or off our analysis viewpoint. Well, that gives us a passage through now for our wires to come through to our switch area. And the only thing we need to add at some point is a way for the wires to come out, to exit, so that they can go to the soldering iron. So in the next part, we're going to look at actually modelling up the holder for the soldering iron itself. We'll also add in the exit point for the cabling, and we'll print off another prototype, which, if all goes well, may be the finished product. But if not, we'll have to make some adjustments. Thank you for watching, and we'll see you next time.